Dear students, we have discussed various topics in finite state machine. We have DFA and its problem, NFA and its problem, and we also learned conversion from NFA to DFA using subset method, lazy evaluation method. In NFA, non-deterministic finite automata, we do have another category called epsilon transition NFA. We call it as epsilon NFA. Let us first define DFA, NFA, epsilon NFA. One by one we'll have a recap. What is DFA? Next state is very clear. Single transition for the given alphabet, and hence next state is clear. What is NFA? Next state is not clear. We can have multiple next state. Multiple transaction for the given alphabet, hence the next state is not clear. What is epsilon NFA? Which means for Q0, if you give 1, it goes to Q1. For Q0, if you give 1, it goes to Q1. For Q0, without any input also it will go to Q1, which means Q0 and Q1 will exist at the same time. You no need to give any input. Without input, it will be there in any places. Transition for no input, empty string is called epsilon, is called epsilon transition. We'll have more detail in the definition. The definition is same as your DFA. It is language with set of strings. I am just taking as an example. Additional term is just epsilon. It do have the 5 tuple components, and the answer remains same. Q, set of all states, everything is remains same. But the transition is as follows. For understanding purpose, I took this particular example. For Q0, 0, it is Q0. One more is there. Q0, 0, one more is there. We'll see. For Q0, 1, it is Q0. Ready. For Q0, 0, it is Q1. For Q1, I am going to discuss. Okay. For Q1, we'll discuss epsilon later. For Q1, 0, nothing is there. Null. For 1 is also nothing is there. Now let us come here. Q0, without any input, it will go to Q1. That's called epsilon. It is Q1. Now all this group come under Q. All this team except epsilon. Okay. All these teams comes under alphabet sigma. And this result is Q0, Q1, both Q0, Q1, null. That is 4 possibility. We already discussed 2 power Q. Apart from that, with this alphabet, you also include epsilon called union. Include epsilon called union. Now this is a new definition, nothing else. So, as usual, the 2 states gives all that remains same. Now union of epsilon is included, nothing else. Let us have a simple problem. Design epsilon NFA which accepts strings of A's and B's with more A followed by 0, that is no input, then followed by more B. Any number of A followed by any number of B, in between no input, that is called epsilon. Any number of A means A power n. That is for your reference I am just giving. Okay, this particular term I am just giving for your reference. Not there in question. A power n, any number of A, followed by epsilon, that is no input. B power n, any number of B's. This is what the idea. Any number means without any input also we have made it. What is the state diagram? Q0, A power n, self loop, I can say A. And then I do have epsilon, no input, I will go to Q1. And again B power n, self loop. That's all, nothing else. So, if you take this 2A, epsilon, 2B, A, epsilon, B, triple A, double B, A, epsilon, B. Just epsilon, it will go here. That's what the meaning. What is the transition function? We will draw the table, very simple. Your Q0 and Q1 is there. A is also input, B is also input, epsilon is also input. Nothing wrong, we can do it. For Q0, A is Q0. For Q0, B is not there, null. For Q0, epsilon is Q1. For Q1 A is not there, null. For Q1 B is Q1. For Q1 epsilon is not there, null. Okay, this is the transition function. And this is the initial value Q0, double circle is final. Okay, that gives you some knowledge about how to bring epsilon into picture. More detail we'll see after epsilon closure. What is that epsilon closure? Because the question here is, if you are in Q0, without any input, you will go to Q1 also. Which means, you are in Q1, Q0 or Q1? Sir, I am in both the places. How come? Because no input itself, I am in both the places. So, you are in Q0 or Q1? Both. We call it as closure. We call it as epsilon closure, E close. What is that E close? I will explain with one small. It is a set of all states, Q0 also, Q1 also, which are reachable from one state with epsilon transition. I have given one big diagram. A, if you give 1, it will go to B. Without 1, will it go to B? No. Without anything, it will go to H also. Right now, my red color pointer is in H, but you may feel, I am in H. No, sir. I am in A also, H also, called epsilon closure. Where are you, sir, now? I am in B also, C also, E also. So, B, C, E, all are friends. C also, D also. No, sorry. If you give 0, then only it will go to D. That is what you should know. D also, G also. Sir, I will give one example. What is epsilon closure of A? A, always start with the same letter. A, it won't go B. Okay. A as well as H because of epsilon. A, comma H. What is epsilon closure of C? C, nowhere else because there is no epsilon. This is input. Okay. This is what the requirement. C only. What is epsilon closure of B? Careful. B, it will go to C also, E also. So, B, C, E. Done. What is epsilon closure of F? Careful. F, because of epsilon it will go to G. Because of epsilon it will go to B. Because of epsilon it will go to C as well as E. Come on, start from here. F, G, B, C, E. F, G, B, C, E. That is the epsilon closure logic. Okay. It's just a general introduction for epsilon closure. More detail when we see some problems in epsilon closure later. With this, I will conclude this particular video lecture. Thank you.